Hello dear friends, welcome to this video. I hope I am streaming live. Let us just start the solution for which I came live, right? As I discussed in my previous video that we will be discussing this problem, right? This is one of the problem of JAM 2013, the paper mathematics. It was asked for 2 marks, and if you choose a wrong option, you will get a minus half. The question is based on the sequence. The given sequence xn is nothing but the product of given sequence xn is nothing but the product of 1 minus 1 by 3 square, 1 minus 1 by 6 square, 1 minus 1 by 10 square, and dot 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 1 minus 1 by n plus 1 by 2 the whole square. What we have to do is we have to find out the limit of this sequence. Okay, so we need to find out the limit. Before finding out the limit, let us just try to understand how this sequence work. So they have given the value of n is greater than equal to 2. So I will start from 2. What is x2? The given sequence will go till your value of n is 2. So on this place of n, I'll write 2. So it is nothing but 1 minus 1 by 2 n plus 1 will be 3 and whole divided by 2 the whole square. So it is 2 cancel. So my x2 is nothing but only 1 minus 1 by 3 the whole square. That means what? My x2 is nothing but the first term inside this. Let us just talk about x3 now. So my x3 will be what? My x3 is nothing but in this formula I should go till n equal to 3. So if I put n equal to 2, I get 1 minus 1 by 3 the whole square, right? And if I put n equal to 3, I'll get 1 minus 1 by 3 times n plus 1 is 4 divided by 2. This is 2, 3 2s are 6, the whole square. That is nothing but the product of first two term inside this. So my x3 is nothing but product of two terms. Then my x4 will be the product of three terms. Then my xn will be the product of n minus 1 terms. Right? So this is something that the sequence has been given. First thing is to understand how the sequence works, and now let us just try to write the sequence in the simple form. What will be the simple form? We just try to write in terms of the product. What I know about xn now? I know that my xn is nothing but product of, it is a product of what? N minus 1 terms, where the terms are obtained by using this formula, right? So I just try to write that. So inside the formula, I should write the value starts from 2 till n. So I just consider a variable k which starts from 2 and will go till n, right? So this xn is nothing but the given sequence which is product of n minus 1 terms, k running from 2 to n, and it is nothing but 1 minus, in the formula I will put the different values of k, right? So it is k plus 1 by 2 the whole square. Okay, let's go further. Now what I do with is just try to simplify that, right? First thing is this 2 will go to the numerator. The next step would be this I can cross multiply over here. So what I ultimately get is my xn is same as the product k running from 2 to n. In the numerator I will have k plus 1. What I did, I just cross multiplied k plus 1 minus 2 divided by k plus 1. And this thing is whole square. Now let us just try to simplify the numerator part. Okay, let's see what is the numerator. The numerator is nothing but k plus 1 minus 2. So it is k plus 1 minus 2. So that is nothing but what? That is nothing but my k square plus k minus 2. So that is nothing but a quadratic equation that we can factorize. So minus 2 should be divided into two parts, so that answer is plus 1. So it is plus 2 minus 1. Right? So that means the given quadratic polynomial is actually nothing but k minus 1 k plus 2, and if I open this bracket, I'll get the required quadratic polynomial. So what we obtain is the numerator is nothing but the product of k minus 1 with k plus 2. So this is same as what? This is same as product k running from 2 to n. In the numerator, what I have in the numerator, it is nothing but k minus 1. It is k plus 2 divided by the same thing, that is nothing but k plus 1, same as the previous, right? Let us just more simplify this, right? What I observe is this is my xn. What is our observation is in this xn, if I see this part, that is nothing but k and the previous term is there in the numerator. Over here k plus 2 and the previous term is there in the denominator. And what I am going to do is I have to do the product of them. If I start doing the product, the terms will get cancelled. Let's see how the terms will get cancelled. To do that, first thing that we do is we just try to separate this two. So in the first half, the product of k running from 2 to n, it is nothing but k minus 1 by k the whole square. Product k running from 2 to n, the product of k plus 2 by k plus 1 the whole square. Right? In the next term, we just substitute the values of k. In the first, if I substitute the value of k, I will start from 2 and then I will keep on going. Right? So it is nothing but on the place of k, if I write 2, so it is 2 minus 1, 1. It is 2. Next time I should write k equal to 3. So 3 minus 1, 2 divided by 3 and so on. Right? It would be 3 by 4 and so on. Till what I will go? I will go till the value of k is n. That is nothing but n minus 1 by n and the whole square. Let's just see the second product that we have. The second product, this. What is that? It is nothing but k running from 2 to n, k plus 2 by k plus 1. If I put k equal to 2, it is 4 by 3. For the next time, I'll do the product with k equal to 3. That is nothing but 5 by 4. The next would be what? It would be on the place of k, I'll write 4. So it is nothing but 6 by 5 and so on. Till what I'll go? I'll go till my value of k is n. That is nothing but n plus 2 divided by n plus 1 and the whole square. As I said earlier, the terms will get cancelled. Let's see which terms are getting cancelled. In the first bracket, this 2 will get cancelled with this 2. This 3 will get cancelled with this 3. And this 4 will get cancelled with the 4 in the next term. Similarly, this n will get cancelled in the n over here. Right? So, these are the things that will get cancelled. So, what I'm left with? I'm just left. Okay. No. How the n will get cancelled? What we are observing is, we are observing the denominator is getting cancelled with the numerator of the first. That means not this n. N will not get cancelled. This n plus 1 will get cancelled with the n plus 1 in the denominator of the previous term. Right? So that means what I'm left? What I'm left is, I'm left with the 1 in the numerator and n in the denominator. Right? So my xn is nothing but, in the first term I have 1 by n and the whole square is there. Right? Let's go for the second half, that is this 4 in the numerator with the 4 in the denominator of the next, 5 with the 5, 6 with the 6 over here. What will happen is, this n plus 1 over here in the previous term will get cancelled with n plus 1 over here. So what I'm left is 3 in the denominator and n plus 2 in the numerator. So it is nothing but n plus 2 by 3 the whole square. Right? So the xn has a simplified version as this. Still we can further simplify this. Let us just try to simplify it further. Since both of them are square, I can take them together and write it like this. So it is nothing but 1 by 3 n plus 2 by n the whole square. Right? What I do? I just interchange this two actually. 3 and n. After this, I just split the denominator in this part. So what I'll be getting is this 1 by 3. First of all, this 1 by 3 square is nothing but 1 by 9. After splitting the denominator in this term, I get n by n, that is 1, plus 2 by n the whole square. So my xn is actually nothing but 1 by 9, 1 plus 2 by n the whole square. And what we want to find out? We want to find out the limit of this sequence, right? We want to find out the limit of the sequence. That means where will xn go if my n tends to infinity, right? That is something that we need to find out. How we can find out where my xn? So what I do, if I take n to infinity, what will happen to this 2 by n, because the only term is nothing but this 2 by n, right? So if my n goes to infinity, my 2 by n will go towards 0. That means if my n goes to infinity, my xn will approach towards, everything else is constant, 1 by 9, 1. But this 2 by n will become 0 when my n approaches infinity and the square. So 1 plus 0, it is nothing but 1. 1 square is 1. So the final answer is 1 by n. That means my sequence will converge to 1 by n. Let's see, is there any option 1 by n? Yes. 1 by n is over here. Right? So option B, 1 by n, is nothing but the limit of this sequence. So this is all about this question. This question took some time, but one of the interesting question, difficult questions. I always feel the questions on sequence and series are difficult in the competitive examination, because if you can solve it during examination, you can. If you are unable to solve it, don't waste your time in that question, right? But does it mean we should leave this topic? No. It means we need to work more hard. We need to solve as many as possible problems. Next time I'll come with one more problem on JAM, and I'll try to cover maximum amount of problem from the competitive exams based on sequence. Okay. Thank you so much guys for watching this video. If you like it, don't forget to subscribe and share it with your friends.